gonna go ahead and continue this video with the Chemistry 1 second semester review, and it's pretty basic. I think it's similar to physics in lengthwise. So we're gonna begin right here by starting out with the stoichiometry. Basically, the general rules of stoichiometry is that you have a limiting reactant; those are the hardest stuff, and percent yield. Limiting and reacting, you have to compare the two substances, two products, and you have to compare which one has less, and that's the one you use. And percent yield is basically the theoretical yield. No, the percent yield over the theoretical yield. I mean the actual yield over theoretical yields. I'm sorry. So actual over theoretical, you get percentage. Always, this has to be always less than that. Just remember that. And you have formula writing, which is basically you have acids, transition metals, molecular compounds. For acids, basically you always put a hydrogen in front, and you have to balance it with the ion. So pretend you have SO4, which is 2 negative, so you have to replace that with an H2 because one H has only a positive. So that's basically simple. A transition metal, you have different valence electrons. So pretend let's take iron. Let's take iron. Fe, and then you got same here, SO4, but this has 2 negatives, so you have to replace that with the 2 when you're writing the name. It's basically very simple, and you got molecular compound. And for example, let's take water, H2O. You can so water basically. Few people write it this way. It's correct, but it's easier to say as water. But you can the true way to write it is dihydrogen, and then monoxide. So that is how you write it. So you just take the coefficients 1, and then you apply it here. And finally, you got the thermal effects. I'm not going to go into that, but just remember, for thermal effects in chemistry is they take joules. They use joules as their specific heat. So usually you have 1 cal over gram Celsius. In chemistry is 4.18 joules over gram degrees Celsius. So remember that. So yeah, just remember that. And finally, we get to I believe gas laws. Yes, we get to gas laws, which is over here. And basically, what you do is you just have to remember that for gases they use Kelvin because of reasons that requires a lot of explanation. But basically, just remember Kelvin is Celsius and plus 273 degrees, or 273, and you get Kelvin. So if you have 0 degrees Celsius, you have 273 Kelvin. And so then we have the Boyle's law, Charles' law, Gay-Lussac's law. We're just going to call that GL. And then we have the combined gas law, which is CG. So first of all, we're going to start with Boyle's law, which is P1V1 equals P2V2, and that basically means pressure of the first gas times volume of the first gas equals pressure second gas times volume of the second gas. And it's basically very simple. Just plug it in and solve for the missing variable. Then we got Charles' law, which is volume 1 over temperature 1 equals volume 2 over temperature 2. This is a comparison between the volume and temperature. This is pressure versus volume, and the final one is the pressure over temperature. And notice that what is the difference between these 3 laws? And the difference is this is the only inversely proportional law. I'm not gonna write that, but these 2 are directly proportional. So just remember that. Pretty basic. Then we got the combined gas law. And that just combines it all, and it applies everything, pressure, volume, and temperature. And use that if you have 2 or more missing variables and you can't solve it using one of these 3. So it's basically it. Oh yeah, and you have also the the partial pressure of a gas, which is you get the pressure of the galactic gas, which is not the full pressure, by subtracting the pressure of the atmosphere, the atmospheric pressure, subtracting that with the pressure of water, because when you're making a gas, your solution, your solvent is water, so you have to subtract that. And that's basically it, and this is useful for gas stoichiometry. And then after that is done, we get to solutions, and in solutions we have what we call a suspension, colloid, and obviously solution. So what are the differences? The differences are there are many differences, but basically a solution cannot be separated. Colloid cannot be either filtered, I should say, filtered, and suspension can. Suspension settles out, colloid remains suspended, and solution, they cannot be filtered out. They are very intact. Solutions, the molecular size of each individual ion is the smallest in the solution and gets bigger to colloid, and then the greatest in suspension, and that has to do with the properties. And finally, we also can use the I believe I forgot the law, but or the method, but this method allows you to if you shine a fluorescent light. Fluorescent light through each of these substances. You have three or identical looking substances, and you can't tell if there's suspension, colloid, or solution. You just shine a light through, like a laser beam, and suspension, it should diffract the light. It should diffract the light. Colloid, it should also diffract the light, scatter it. For solution, it just passes straight through because it is all intact. So basically, that is it for that. We also get the we also determine the solubility of a substance via the size of the ion and the charge of the ion. And we have two things, dissociation and ionization. And the difference is dissociation is you write the equation for ionic compound, while for ionization you write it for acids and molecular compounds, or polar molecular compounds that can dissolve one another. And main differences also you have double arrow and single arrow. Single arrow means it's soluble. Double arrows insoluble, or weak gases for ionization. Solubility and rate of dissolving. These two are very similar yet very, very different. Solubility is how much solid can dissolve in a solvent, while rate of dissolution is the rate at which a solid dissolves in a solvent, and that is the main difference. So this is how much, and this is the actual speed. Yeah, the speed. So don't get those mixed up. Those are very important. And basically that is it for chemistry. Very short, and this is the physics. Very short, very okay, and hope you guys do good. And that's it.